What's up, everybody? It's Mrdothemath here, and today we want to talk about slopes of a line, right? In order to talk about slopes of a line, you need to know where you're graphing these things. So what I have here is Cartesian coordinate plane. And there's some basics to this that we want to talk about first. Um, Cartesian coordinate plane contains an x-axis, which goes from left to right, and a y-axis, which goes from north to south, goes up and down, right? The middle of this coordinate plane is called the origin, right? This is the place where both the x-axis and the y-axis are zero. And if you break this down to like just an axis by itself, what you'll see is a number line. And in a number line, you have a positive side of the number line and a negative side of the number line. All right. And so for the x-axis, the positive side of the number line is on the right side of the origin, and the negative side is on the left side of the origin. And then for your y-axis, the positive portion is at north of the origin, above the origin, and the negative is below the origin, right? The way that you identify each section of your coordinate plane is counterclockwise, and they're called quadrants, right? So you have the first quadrant here, the second quadrant, the third quadrant, and the fourth quadrant, right? Your quadrants are numbered counterclockwise. Now, keeping in mind what I talked about when we talk about these number lines here, that helps you identify what those numbers look like. You know, when you look at the coordinates, right? Each coordinate has an x and a y label, right? X and a y relative. All of this is interconnected, right? In quadrant one, though, your x's and your y's are both positive, right? Because look, it's on the right side of the of the origin and above the origin, right? In quadrant two, the x is on the left side, which makes it negative. However, it's still above the origin, so it's positive. Quadrant three, they're both to the left and underneath the origin, so they're both negative. And then for quadrant four, it's on the right side of the x-axis and below the origin, right? Negative, right? So this is what it looks like. Quadrant one, positive, positive. Quadrant two, negative, positive. Quadrant three, negative, negative. Quadrant four, positive, negative. And so when you see numbers or your coordinates, you could tell where your that point would fall within the where that point would fall within your coordinate plane. So for instance, if I had like -2, -2, right? They're both negative, so they're gonna fall within quadrant three. If I had +2, -2, that's a positive x, a negative y will fall within fourth quadrant. You get what I'm saying? All right, good. All right, let's move on. Now we were talking about slopes, right? The slope is the manner in which a line either rises or falls, right? So so that being said, the slope tells you the incline of a line, right? There's four different ways that a line will be situated. You'll either have one going in this direction, which would be considered a positive slope, this direction, which would be considered a negative slope, horizontal line, or a vertical line, right? So a positive slope is going to go from quadrant 3 to quadrant 1. Negative slope is going to go from quadrant 4 to quadrant, that's 6. 4 to quadrant 2, right, going into us. And a negative slope is going to have, horizontal line is going to have a zero slope, and a vertical line is going to have an undefined slope. Because when you look at this, all right, when I say slope, the first thing that kids usually say is rise over run, right? That's the first thing they say, right? And I'm going to come back to this. The first thing they say is rise over run. Rise means the change in y, right? Because the y-axis goes up and down. The run is the change in x, left to right, because the x-axis goes from left to right, right? So your slope is going to tell you at what rate your line goes up, and at what rate your line goes to the left or to the right, right? So a rate it goes up or down and left to right, right? So when you look at something like this, horizontal line having a zero slope, that means it's going to have no rise and it will have a run. So there'll be a number there. For a vertical line, though, it would have a rise. It's going up, but it has no run. It doesn't go from left to right. And so because you don't have fractions that have a zero denominator, it's known as undefined in regards to the slope. Now, for a positive slope, you're going to have a positive rise and a positive run. A negative slope, you're going to have either a negative rise or a negative run, right? Either one of those things are going to be negative, right? But the question is, how do we figure out what the slope is, right? If we're given 2 points, there's 2 ways to figure out the slope. One is to use the slope formula, which is the safest way. And then the other way is to like count. And because I don't have a grid here, we're going to use the slope formula, all right? So let us calculate our rise over run, right? Like I said before, slope is the change in y over the change in x, right? That being said, that means that we need to know the slope formula. M is the symbol for a slope. And because it's the change in y, it's going to be y2 minus y1. Change difference, right? So it's always going to be a minus sign in between it when you're thinking about the formula. And it's going to be x2 minus x1, right? Why did I say 2, x2 and x1 and y2 and y1? Pause the camera. Think about that. I'll tell you why. Because geometrically, or when we talk about geometry, right? In order to make a line, you need 2 points, right? You need 2 points to make a line. Any 2 points, anywhere in the world, anywhere in your space, can create a line. You can draw a line from point A to point B, or this point to that point, right? With that being said, in order to find the slope, all you need is 2 points, right? 1 point being x1, y1, and the other point being x2, y2, right? With that being said, what you would do is when given 2 points, 2 coordinates, you would just substitute these values into this formula here, okay? Substitute these values into this formula here. Y2 minus y1, x2 minus x1. Now, because I'm left-handed, I kind of do things backwards. And so when I used to teach my kids in the past, I would always say like y1 minus y2, x1 minus x2. And that's correct as well. The main thing is making sure that you stack the corresponding coordinates with each other. So the corresponding x with the y and the corresponding y with the x. As long as you do that, you're going to be good when you talk about calculating it. All right, so let's actually calculate something. Let's actually find the slope of a line. All right, I'm going to put the slope formula back in this corner here so you can see it. Y2 minus y1 over x2 minus x1. All right, so you got the slope formula here. If I gave you 2 points, so 2, 4, and 3, negative 5, right? All right, the first thing you want to do is identify your x's and your y's, right? Identify your x's and your y's, right? With that being said, 2 represents x1, 4 represents y1, 3 represents x2, 5 represents y2, okay? Once you have identified the x's, you can substitute it into the formula, sub in the formula. All right, the formula being y2 minus y1, x2 minus x1. So it'll be y2, which will be negative 5, minus y1, minus 4, over x2, 3, minus 2, right? One of the common mistakes that we make when we're calculating our slope is we put the x on top and we put the y on the bottom, right? Again, the y goes on top, so that's where this 5 came from. That's where this 4 came from, right? And the 3 is like that. After this, you just simplify. Yeah, that's about right, I guess. Simplify. Let's do the math, right? Negative 5 minus 4 gives you negative 9. 3 minus 2 gives you 1. So your slope is actually negative 9 over 1, or negative 9. All right? With that being said, it'll be a negative slope, which means it'll be going in that direction, right? Let's do another example. All right, I'm just spitting out these numbers off the top of my head. Let's see what I come up with. Let's say 5, 5, and 7, negative 7. All right, let's do that one. All right, 7, negative 7. Again, identify x and y. So this is x1, y1, x2, y2. right? Then substitute into the formula. Y2 is negative 7, so it'll be negative 7 minus y1, which would be minus 5. And then we got x2, positive 7, minus x1, positive 5. Okay? Then simplify. Do the math. Do the math. Right? Negative 7 minus 5. Same sign. Add and keep. Different sign. Subtract. Same sign. Add and keep the sign. Different signs. You're going to subtract. So you get negative 12 over 2. 7 minus 5 is 2. Then you can simplify this. Negative 12 over 2 can be simplified to be negative 6. Oh, look at that. We found another negative slope. So the slope is negative 6. Negative 6 over 1 or negative 6. Okay? Now, our line would again be going in this direction. And what you'll find is the bigger the slope, the steeper your line is, right? Because, like, again, rise over run. Rise is going to go up 6 spaces. So if you started at this point here, you're going to go up 6 spaces. 1, 2, 3, 4, 5, 6. This is just a ballpark, just to give you an idea what it would look like, right? So I'll go up 6 spaces, and it would go over to, since it went up, we're going to go to the left. We're going to go to the left 1 space. 1, 2, 3, 4, 5, 6, to the left like that. So your line will look something like this. It'll be super steep. Like, it's almost like close to a straight line. With that being said, the smaller your slope, the flatter your incline, or we'll just say it that way because I can't think of a different word right now. The flatter your incline. Okay, let's do one more example of slopes using the slope formula. All right, so let's see if we can get a positive one. So 2, 3, and 1, 5. 2, 3, 1, 5. Identify your x and your y. X1, y1, x2, y2. Y2 is 5, so it'd be 5 minus y1, 3, over x2, 1 minus 2. Okay? Simplify, do the math. 5 minus 3 is 2. 1 minus 2. 1 minus 2, 1. Negative 1. Ooh, another negative slope. All right, so your slope is going to be negative 2. All right, the way negative 2 looks is we go up 2, bop, bop, to the left 1. Look at that. It's already flatter than that 1, 6, right? 1, 6 would have been something like this, right? It would look something like this. 2 like that. And so the smaller your slope is, the flatter your line gets, right? And so honestly, in a nutshell, this is the things that you need to know about a slope, right? And like I said, you got 4 types of slopes. You got a positive slope, bop, negative slope, this one, a horizontal slope, 0, and an undefined slope, which is a vertical line. Okay. This is kind of like the preface to everything that we need to know about writing equations for the lines and graphing lines, right? And so I hope that this time that I spent on slopes was beneficial to you. And if you like this, don't forget to like this video and subscribe for more videos like this. Mr. Do the Math, out.